Hey there, welcome back. This is Mr. Gardner here. It is the week of May 4th through May 8th. So if you're a Star Wars fan, May the 4th be with you. And our next assignment here deals with Table G. And so what you need to be looking at is the actual reference table, the New York State Chemistry Reference Tables. Table G, it's on page 3. It says solubility curves of standard pressure, or at standard pressure, excuse me. And this is basically what we're looking at. Now, the one that you have in your reference table is slightly different in the terms that, maybe it looks a little bit different over here because of, there's a slash here instead of, the words of. But also, and what this really means is, for example, if we look at this, it says solute per 100 grams of H2O, which of course is water. So that means how much stuff am I dissolving in 100 grams of water? Now, if you've paid attention throughout the year, you should know that the conversion of grams of water into a volume, a mass into the volume, is a 1-to-1 ratio based on the density of water. And so this is really a 100 milliliter sample. So think about a beaker of water that's 100 milliliters. These are the samples that can be put in them and be dissolved. And if you notice, each material has its own unique curve. The general trend as we get warmer, we go from left to right, most of them go up. Okay, overall, most of them go up. There are a few that come down, and that's often the case with gases. And so, for example, ammonia is a gas. HCl can be a liquid, but of course, it can gas and bubble off. And so, most of the time, the gases usually would go down when things get warmer, but solids usually have the ability to dissolve more when it gets warmer. Think about dissolving sugar in, a cold beverage like cold tea or a Kool-Aid versus dissolving something in hot chocolate or coffee or tea. That sugar is usually going to dissolve a lot faster in a warmer substance. So the activity that you have through here, there are 15 questions. I'm going to do a few of each kind of style so that by the time you're done, you'll have about 11 or 12 left to fill in. So this is the worksheet you should have downloaded or you have access to in Google Docs, interpreting data from solubility curves. Again, use table G. And how we interpret it is based on the question, we really want to find a point. We typically want to find a point on the curve based on either a temperature that's given or based on an amount of solute or material that's being dissolved that's given. And then go to the curve and either read down to find out the temperature or to go to the curve and then read over to find out the solute. So if we take a look at the first one, again, I'm going to do there's a couple different varieties through here. But for example, number 1, 2, and 3 are pretty much all the same. The wording is the same, so the process is the same. So I'll do like one of those and then you'll do the other few. And then there's a couple other that are similar to that. So number 1, what is the solubility of potassium nitrate in 100 grams of water at 65 degrees Celsius? Now, in case you forgot, if you flip your reference table open so that it's open like a booklet, so you see table G open, and on the left side you actually see table E. Table E has all your polyatomic names and the polyatomic ions, so you can actually look up what the formula is for those in case you've forgotten. So for example, potassium nitrate, potassium comes from the letter K, nitrate is NO3. So we need KNO3. That would be from table, anything ending in ATE or ITE, we usually find on table E. Okay, we learned that earlier when we were still in class together. All the other things that end in IDE are usually found on your periodic table or table S, but there are some exceptions like cyanide and hydroxide, which are on the reference table E for polyatomic. So potassium nitrate is this one right here. So we got to make sure we're looking at the correct curve. See where the arrow is attached and see there's my KNO3, potassium nitrate. So this is my curve right here. And the question says, what is the solubility of potassium nitrate in 100 grams at 65 degrees? So that means I need to go over to 65 degrees, which is right here. And then I'm going to follow all the way up in between. And 65 is halfway in between those two lines. It's about right here, right where it crosses this line. Okay, that's where 65 degrees is for KNO3. When I read over there, that's 120 grams. So for example, this answer is 120 grams. Okay, 120 G's, 120 grams is what we would add there. And so we're just going to get rid of a couple spaces. That's about our answer for for that first question. Again, we went over to 65 degrees, and then we went all the way up till it hit the line, and we see that line crosses at 120. Okay, so that's the solubility. That means at 65 degrees, I can dissolve 120 grams or up to 120 grams. If I dissolved more, it would sit at the bottom. I would still have some left over. So you maybe have gone to a restaurant and they only had regular iced tea and you put in a sugar pack and the first pack dissolved, but then you wanted a little sweeter. So the second pack was thrown in there and that didn't dissolve all the way. It just went to the bottom. And so it can only dissolve a set amount. Every single material is a little bit different. Okay. So numbers 2 and 3 are going to be just like that. You're going to go over to the temperature and then you're going to figure out. Notice where it says in 100 grams of water. That's just extra information here. That just tells you that this is the standard based on the fact that it's 100 milliliters of water. Now, it is proportional. If I were to double the amount of water, that means I can double the amount of sugar I can dissolve. If I cut my water in half, that means the amount of sugar I can dissolve or salts I can dissolve is cut in half. And so a lot of these are salts. Okay, these are different types of salts. So again, if I were to double my water, I could double the amount I could put. So if I had 200 grams of water here, this would be 240. I could double it. If this was only 50 grams of water, I would have to cut it in half, so I could only do 60, which is half of that. If I only had 10 grams, let's say I just had 10 grams of water, I reduced it by a tenth. I would do the same thing here. I would reduce this by a tenth, and I would only be able to dissolve 12. Okay, so it's directly proportional. If I double the amount, I double how much I can do. If I cut my amount in half, I cut in half how much I can do. If I multiply it by 8 times how much I put in there, how much water, then I can multiply by 8 times the amount of salt or sugar. Okay, hopefully that makes sense. So numbers 2 and 3 are basically identical to this, okay? Number 4, pretty similar. What is the minimum temperature needed to dissolve 80 grams of potassium nitrate in 100 degrees water? Now, the process is the same, but now I'm asking you what the temperature is. Here we were asking you what the grams were. So we're going the other way around because now it's giving you grams where before I gave you the temperature. So now I got to find my grams first with my chart, and then we need to go to the temperature. So this says, again, we're going to use the same example. We're going to use potassium nitrate again. And it says 80 grams. So I'm going to go to 80 grams. The grams are on the side. I'm going to go to 80 grams, which is right there. And notice where I hit KNO3. Notice make sure we're using not this curve, because this curve goes up here to actually sodium nitrate, NaNO3. We want to be in the potassium nitrate curve. So I'm going to start here and go all the way over. Notice it's just a little bit before this line. And so if we bring our line down as close as we can to estimate, we're at about right here. So again, we went to 80 degrees. We go all the way over to the line, and it's before that next solid line. So we're going to come all the way down, and we're going to estimate. Our estimates will have a little bit of value to them. So we're going to estimate it's a little bit past the halfway point. The halfway point would be about right here, and it's about right here. So maybe about 47. Okay, I'm going to go with about 47 or 48. So it would take 47 degrees in order to do that. So if you said 47 or 48, there you go, okay? So that would be 47 or 48 in degrees Celsius. I'm not going to play around with my symbols right here, but you would have to have the unit of degrees C for that. And so number 4 and 5 are basically going to be the same concept. You're looking for grams first and then figuring out temperature. Again, the 100 milliliters, or excuse me, the 100 grams, which really is 100 milliliters of water, is just extra info to let you know that this is a standard. I talked about doubling and cutting in half. When we get down to some of the questions down here, notice it says in 50 grams of water, 200 grams of water. So this one's been cut in half. This one's been doubled. 25 grams of water has been divided by 4. So your amount would have to be divided by 4, okay? All right, so 4 and 5 are very similar. Number 6, at what point do they have the same solubility? All you have to do is find potassium nitrate and find sodium chloride. Find them on the chart and see where they cross. Okay, they would have the same solubility, meaning again, at what temperature do they dissolve the same amount? That's at a point that they cross. So there's your hint to answer number 6. Number 7 says if I have 15 grams of potassium iodide at 20 degrees Celsius, how much more can I add to be saturated? So let's find potassium iodide. Potassium iodide is Ki. Now that's the one over here in the top corner, Ki. 15 grams is way down here though. And it talks about, again, 15 grams at 20 degrees Celsius. So at 20 degrees Celsius, if we go 20 degrees Celsius, that's something that I know from the question. And if I go all the way up to the line for Ki, notice that's beyond this point. Now, there's no number up here, but we know by the scale, 20, 30, 40, this would actually be 150 for this line. That's about halfway. So at 20 degrees, I know I can do 145 grams. Okay, so if we bring up a calculator, I know, for example, I'm just going to type this in, move this out of the way a little bit. Scroll up our question. I know that at, again, 145, so there's our number there. I have 145 that I can dissolve. Again, how I got that, we're on number 7 here for the example. Again, this part right here, potassium iodide at 100 grams of water at 20 degrees Celsius. So 20 degrees Celsius, I go all the way up to potassium iodide, which is Ki, and I see that it can hold, it has the ability to hold 145. It's about halfway in between 140 and 150. So I know it can hold 145. It says if 15 grams are added, then it says how much more must be added to saturate the solution. So if we're down here at 15, I've added this much here, 15, I can go all the way up to 145. Sorry, we're on this line. If I've added 15, I can go all the way up to 145. How much more can I add? Okay, so if I've already put 15 in, and I can add a total, like a maximum of 145, all we have to do is subtract that number and subtract the 15. I can add in an additional 130 grams. Okay, if I'm already at 15 and I'm going to make it all the way to 145, that means I'm going to add in an additional 130 grams of substance, or I can add 130 grams of substance. Okay, number 8 is just like that. Again, water, sodium chloride at 100 degrees, how much more can be added? Number 9, it's saturated. If it's heated, how much more? Now, this is very similar, but it's slightly different. So let's take a look at this one more in depth. I'll help you out with this one too, because these two are very similar. Actually, all 3 of these, 9, 10, and 11, are very similar. And so 100 grams of water are saturated with potassium chloride. Potassium is K, chloride is Cl, so KCl. So we're dealing with this one. Again, look at where the arrow is going. It's this curve right here that goes all the way down. We want to make sure we're looking at the right one and we're at the right temperature. So 100 grams are saturated at 35 degrees. So if we just take a look at that, at 35 degrees, KCl at 35 degrees, so here's 35 degrees, and there's our KCl chart. Now, it's right underneath the 40 line. So it's in this little range. There's going to be a little range in our answer, but we're going to guess this is about 38. Okay, let's just say this is 38 grams. It says it's going to be heated to 95. How much more can be dissolved? So if we go to 95, if I go to 95 degrees and I go up to my KCl chart, notice I'm halfway between 50 and 60. Okay, so again, at 95 degrees, and I go up to my KCl line, at estimate, I'm at about 55 degrees, okay? But we started at 35. So at 35, we could only dissolve about 38. So we have a difference. We can hold 38 here, and we can hold about 55 over here. Again, there's going to be a range. So all I would do is subtract those. I know, again, I can hold, we'll clear this out. I know I can hold 55 at 95. Again, if we go to 95 degrees, and if we go up to the KCl line, it's about 55. It's about halfway there, okay? And it said it was originally saturated at 35, but it was heated up. So at 35, it could really only hold about 38. Okay, right here is about 38 grams. So the question is, how much more can I add? If I warm it up, notice if I'm down here and it's cold, I warm it up, I can dissolve more. Notice the line goes up. So I know I can do 55 at the high point, At the low point, I know I can do 38. The difference is 17. Okay, so our answer for number 9 would be 17 grams, okay, because we can add that much more. Okay, hopefully that makes sense. Question number 10 and 11 are just like that, pretty much 12. What 12 is going the opposite direction. Okay, notice, 20 going to 50. This is 50 going to 100. This is 90 going down to 25. These are the opposite. So these three are warming up, or excuse me, these two are warming up just like number 9 was. Number 12 is just the opposite. Start at the higher temperature and figure out how much is at the lower temperature. But again, if you've noticed in every single case we've done, we've either gone to a temperature and find the line to figure out the grams, or we've started with the grams and went over to the line and then found a temperature. So you need to always make sure you're finding those points. So on your reference table, you physically have a copy of your reference table, or you should at home. You should be able to use a pencil and actually write on your reference table, and you can always erase it later. If you have to use an image, you can search table G online, and you can actually go forth and use that to the best of your ability. It just might be a little bit harder, and you can have some scrap to go with it. Now, the last one I'll do with you as an example goes on the concept again of being proportional. So how much potassium nitrate will dissolve in 50 grams of water at 50 degrees? So again, we started with potassium nitrate. We're going to finish with potassium nitrate. KNO3, we're at 50 degrees. So at 50 degrees, I know KNO3 is right there. And just for the sake of this being easier, we're going to say it's right in between. We could argue 83, we could argue 84. We'll make it simple. We'll just say it's 80. Well, for the sake of math, we'll say this is 84. Okay, so I know at 50 degrees, KNO3 will dissolve at 84 grams. But I only have 50 grams of water. So what I need to do, if I have half the amount of water, because this table is based on 100 grams, if I have half the amount of water, that means I have to half my answer. So we said, for example, we'll clear this out, we said 84, we said 84 grams, but I need to divide that by 2, which is 42. Okay, and we divide that by 2, we get our answer of 42 grams. 42 G's, not 42 sixes. So, and that is how we use table G. So your activity, I've given you 1, 2, 3, 4, 5 answers. And again, assuming you follow along, maybe you need to follow along and stop and answer the first, go back and watch. If you didn't, watch number 1 again. Watch my demonstration for number 1, then answer 2 and 3. Watch my demonstration for 4 and answer 5 and 6. Watch my demonstration for 7 and answer 8. Watch my demonstration for 9 and answer 10, 11, and 12. Watch my demonstration for 13 and answer 14 and 15. So you have 10 questions to answer, and then submit it when you're done, all right? Take care, have a great week, keep working hard, keep, try to stay sane, stay healthy, and, unfortunately, the way things worked out, we won't be able to meet, but, maybe someday we will touch base again, whether it's at an event, a game, especially if you're a senior. We'll be staying in touch. Let me know how I can help if you have questions. But the key thing, take action, and you can get yourself a good grade, all right? Take care. We'll talk to you later.